Lee, and I will be the moderator for today's webinar. I'm excited to be joined today by Jed Saldwell, Global Open Data Lead at Amazon Web Services, and Bo Laguerre, Enterprise Products and Solutions Manager at Harris Corporation. During the presentation today, Bo and Jed will discuss how the latest cloud technology is used to enable quick and better decision-making of geospatial information anywhere, anytime. In this webinar, they'll do a quick intro of Harris and AWS. Then they'll cover how AWS approaches sharing data in the cloud. Harris will demonstrate the effectiveness of using cloud-based data on desktop and cloud-based analytic platforms. And then we'll finish up with Q&A. I've muted the phone lines for all the attendees, so if you have any questions at any point during the webinar, feel free to enter them into the questions chat box, and Bo and Jed will try to answer as many as they can at the end of their presentation. I'd also like to mention that a recording of this webinar will be emailed to you in the next 24 hours. And now I'm going to turn things over to our first speaker, Bo.
Hello, everyone. My name is Bo Laguerre. I'm with the Harris Corporation, and I'm going to be one of your presenters today. First thing I'm going to do is go through a quick overview of the Harris Corporation, the host of the webinar, along with Amazon Web Services. The Harris Corporation is a large worldwide corporation. We have 22,000 employees. 9,000 of these employees are engineers and scientists. We are an international corporation supporting customers in more than 125 countries. We're very proud of our industry-leading investment in research and development activities that allow us to create a broad portfolio of leading-edge, cutting-edge technologies that lead into strong franchises. We have key experts in certain technology areas, and we have a proven track record of innovation and success. The part of Harris that is giving this webinar today is the Harris Geospatial Solutions Group. We are the group that offers commercial software and data that specialize in scientific programming and geospatial exploitation. Our products are listed on the screen, starting with our IDL scientific programming language, the ENVI software, which we'll be focusing on today, our Jaguar web-based geospatial data management solution, and we also now have the ability to sell commercial satellite data, and we are the owners and the flyers of industry-leading Geiger mode LiDAR technology. The technology that we're going to focus on in this webinar, talk about how it works in cloud technology, is the ENVI technology, a very mature analytics platform that supports many data types in the type of data that is required to perform advanced geospatial analytics, such as multispectral, hyperspectral, SAR, elevation LiDAR, and thermal data. And on the screen here, we have examples of various types of data from LiDAR to SAR and down to multispectral and hyperspectral. ENVI comes with a wide variety of analytical capabilities, ranging from anomaly detection, change detection, many forms of supervised and unsupervised classification, which can be used then to perform thematic change detection, also pre-processing and calibration analytics such as orthorectification and atmospheric correction, and some pre-packaged workflows that work through capabilities such as the Spear and Thor tools. You can go to our website, harrisgeospatial.com, after the webinar to get a full range of capabilities, briefings, and content. I'm now going to turn it over to Jed from Amazon Web Services.
Hi, thank you, Bo, and thank you for having us on your webinar. So first of all, I'm just going to talk a little bit about what Amazon Web Services is and what the cloud is. We define the cloud as the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. It's a very simple definition, but there's a lot of power in that. What we do is we provide storage, networking, computing, database services, and many, many other application services and services that you can use to over 1 million customers around the world to build all sorts of applications in the cloud. And so what this allows people to do is to build applications without ever having to acquire their own hardware and to manage their own hardware. And almost more significantly is that pay-as-you-go pricing element, which is that people only have to pay for what they use. So if you need computing resources during the day, but you don't need them at night, you can turn off cloud resources at night and not pay for them. Similarly, when you're procuring storage in the cloud, you only pay for storage that you use. So you don't buy a huge array of storage and worry about filling it up or running out of space. You simply pay for what you use as you need it. And we serve all sorts of customers, many of which who need to work with geospatial data, particularly in the public sector. We serve over 2,300 government agencies worldwide. So next slide. And so as I was introduced, I run our Open Data program, and this slide sort of describes what we see as an opportunity for open data and sharing data in the cloud, which is that acquiring data can be extremely cumbersome, especially for people who need to work with data that is large, like geospatial data and imagery. And so a lot of that data tends to be on tape somewhere that needs to be acquired, shipped somewhere, put to disk, and make it to a server where people can analyze it. And so we see that as a huge opportunity for us to add a lot of value by making data available close to computing resources so people don't have to acquire it, which I'll explain on the next slide. So when data is made available in the cloud, it allows people to take their algorithms to the data rather than taking data down to their algorithms. And what this means is basically, you can think about it in very simplistic terms. Code to process data is much, much smaller in terms of bytes required than, let's say, hundreds of terabytes of satellite imagery. What I show here in this diagram is Amazon S3 and Amazon EC2. These are two of our primary services. S3 stands for Simple Storage Service, which is object storage in the cloud, and EC2 is Elastic Compute Cloud. And what we're going to talk about today is that we've made some data resources available publicly in Amazon S3, geospatial and raster data resources that anybody can access. And what that's done is allowed people, students, researchers, people who don't have data centers or large local computing resources to turn on EC2 instances in the cloud to process that data. I really like the quote that's on the slide. This is from a presentation given by Paul Ramsey, who's one of the lead developers of PostGIS, or lead contributors of PostGIS, who talks about how working with Landsat data that's available in the cloud has really changed the game, because previously, to work with Landsat data, you'd have to download, gigabytes of data, which took a lot of time, and actually gave them a lot of leisure time. But fortunately or unfortunately, that leisure time doesn't really exist anymore, because when you're acquiring Landsat data from S3 and sending it to EC2, as he says, it barely affords time to touch your toes. Next slide.
Okay, thanks, Jed. So before we get into how ENVI is using AWS in this cool new way to consume data, I just want to go through what model ENVI uses for traditional data consumption. And this is probably the model that a lot of you are doing today. An ENVI user who wants to exploit data today typically uses a menu option on the desktop version of ENVI called File Open. And this exposes you to over 100 different file and sensor types represented in this very busy word cloud on the right of the screen. This paradigm assumes that the data is on disk, and it kicks off a disk-based file reader, which is very fast, but it's limited because before you even get to that step, you would have had to download the data, as Jed was mentioning in the prior slide, which can more often than not these days get into the gigabyte range and take a long time. Also, when new sensors come on board, we have to update the software to get the support that you need for metadata and other types of advanced support. The reality that's occurring right now is that with the plethora of data that's coming online, this data is higher resolution and it is very large, and it's becoming hard to manage on local storage. And it's causing way too much duplication. The data needs to be shared. It also needs to be put in a common place where we can access it. So this is our traditional data consumption model today in ENVI. So now we're going to go to Jody with our first poll question. And that poll question is, how do you currently open your data into your analysis and exploitation software?
Hello, everyone.
All right, so it looks like W files on disk are 68%, and then 22% is web services, and 11% I'm not sure.
So that is actually quite promising, because I think a couple years ago those results would have been a lot higher towards files on disk. So the world is moving into the direction of web services, which is, we think, a very good thing.
Okay, so yeah, and we agree, obviously, at Amazon Web Services that this is a good thing. Now is probably a good time for me to explain a little bit about why AWS cares about open data and has an open data program. The simple story is that we have a lot of customers that rely on open data from both ends. And what I mean by that is that we have a lot of public sector customers who, because of policy or because of their mission, they're seeking to share data and make data available to people. And we work with them to help them use the cloud to accomplish that. And then on the other side of the coin, we have customers in the commercial sector, like Harris, like Digital Globe, like the Climate Corporation, and many others, that they rely on the availability of open government data to do their jobs. Their products would not exist or be very useful without the availability of open data. Next slide.
So how are we going to support this? How can we make it possible for the 60 to 70% of you and others who are still using data on disk? How can we move from this file open paradigm to support the open data paradigm on Amazon? There exists technologies today within ENVI to consume web services from such sources such as OGC Web Services, the Amazon Web Services, etc. We can also provide custom query tools to search and discover specific data sources, so that you don't have to go and use open websites to search and discover this data and download the whole thing. We can make that happen right within the ENVI environment. An example of this is a query tool, which we're going to demonstrate in a couple minutes, called the Landsat 8 query tool. And this connects to the AWS Landsat service, which Jed will go into details in a couple slides, and allows you to search and bring results right into the ENVI platform. So this really leads into our overall goals for open data in the cloud. We really are moving towards providing an alternative to file open, and that alternative is search and discover. So instead of file opening to a file on disk, we want to enable the search and discover process, map-based, project-based, within the ENVI environment, whether it's the desktop or the cloud. This will expand the amount of data that can be brought into focused problems through cloud data sources. So it'll be a lot more straightforward of bringing in data from Landsat Data, from Digital Globe, in your area of interest, instead of going to search and discover websites or calling your vendor. We'll be able to find all of those sources within the ENVI platform. We also are going to be able to bring cloud-based data archives to derive data trends not possible through localized data. And what I'm talking about here is time, doing temporal analysis. It's very difficult to do large-scale temporal analysis, most probably because of the amount of data you have to bring onto your local system to do this. the advent of the cloud and storage of large archives allows you really just to go and dig into that data on the cloud instead of bringing it all down and searching, discovering it just based on area of interest. So this really does help us expand the addressable size of imagery-based analytics in the cloud, because we don't have to worry about the user bringing all the data down to the user. And it also allows us to deploy analytics to the connected world using cloud-based analytics platforms connected with cloud-based data sources. And we're going to show some demonstrations of that in a couple slides. So the next one you have is our second poll question. Go ahead, Jed.
I'll launch it. What is your level of AWS usage? $65 do not currently use AWS. 17% are evaluating, and 10% run the test dev workloads, and 8% run one or more production workloads.
All right. Well, that's good to know. Now I get to talk a little bit more about AWS and what we're doing. So first of all, Bo's goals, the goals that Bo described for Harris and working with data in the cloud, obviously, we agree with. We're definitely aligned with those. And I want to add just a little extra commentary to that, which will sort of set up the explanation for why again we're working with open data and making data available publicly. Which is that we can also see very large trends, sort of macro trends in technology. And these ones are quite obvious to most people. This isn't anything sort of proprietary that we can see at Amazon, but you can see this everywhere, which is that computing power is becoming more efficient continually, because of Moore's law. So computing power is becoming cheaper in a way. Similarly, storage density is continually increasing, and which makes storage a lot cheaper. But one thing, so processing power and storage are going down quite rapidly, but the cost of bandwidth, or rather the availability of bandwidth, is not increasing. So the availability of bandwidth is not increasing at the same rate. And so what that means is that because of reduced cost in processing power, we can produce more data than we ever could before. Because of the reduced cost of storage, we can store more data than ever before, but we can't move it around quite as easily. And that makes the cloud sort of the center of gravity for data analysis. Now, so we can sort of look into the future and see that as we start working with greater and greater volumes of data, it's only natural for that to happen in the cloud. So we have this thing called the Public Datasets Program, which is sort of our lab for exploring different ways to stage data for analysis in the cloud. And a little over a year ago, we committed to make up to a petabyte of Landsat data freely available for anyone to use at no cost on Amazon S3. And so what you can do right now is you can find in an Amazon S3 bucket, we call them buckets in S3, are all Landsat 8 scenes from 2015 until today. And we also include a selection of cloud-free scenes from 2013 to 2014. And we're continually bringing in new scenes as soon as they're available and making them available to people. Next slide. Now, typically, so like I said, the Public Datasets Program is our lab for experimenting with ways to stage data for analysis in the cloud. So we didn't want to just take the data as it exists in USGS's servers and then just make it available in S3. We didn't want to treat S3 simply as like a big FTP server. It's actually a great place to serve up data for analysis. So what we do is we get each scene as it's made available from USGS, and to anybody who's worked with Landsat data before, you might know that it comes as a tar archive that includes all of the various geotiffs that correspond to different bands of data, different wavelengths of light. So what we do is we receive each tar archive from USGS, take it to an EC2 server, and unpack the archive, and then make each individual TIFF available in S3. And what that does is it basically creates an API to access the data. so that if you know the path and row for the Landsat scene that you're looking at, you can look up which scenes are available, and then you can request just the geotiff that corresponds to the data that you want. Next slide. And just another point of clarification in case you didn't already know about Landsat. There's a lot of data in Landsat. So we bring in about 0.6 trillion pixels of data every day that's produced by Landsat and made that available in Amazon S3. And anyway, what's remarkable about this again is that anybody can come and access this data, and they can analyze it on demand without having to store it themselves. They don't have to make a copy of it and pay to store that persistently. It's just available in that bucket publicly for them to query whenever they want. Next slide.
So let's now show a tool in action. So we're going to start with showing a tool that does search and discover from the ENVI desktop. So what I'm going to do is I'm going to display and do a live demo here. So I have here the ENVI desktop system. I have the world loaded, just some outlines for reference. And what I'm going to do is I'm going to run a tool that is an extension to ENVI called the Landsat 8 Query Tool. So what this tool allows me to do is search the Landsat archive that Jed described available on Amazon with common filters such as cloud cover. I can search just a specific path row, and I can also search a date range. So by default, what I'm going to do now is I'm going to search all of the data that's in the archive, less than 10% cloud cover, in the last week, and show those footprints in ENVI. And what you see here is you can see that I've gotten back results that show the ID in the database, but also things that you should recognize, such as the name of the data set, the dates, the product name, the cloud cover, the path, and the row. In ENVI here, I have an active interface now that I can go to and zoom in and search and see what scenes were collected in the last week, and you can see the coverage pattern of Landsat. I can look at the query results, and I can view their attributes, which will give me data about, they'll give me even more insights into that, such as their acquisition date, the area that they were covered in, their center coordinates, etc. And I can go and actually use a selection mechanism within ENVI to find a specific data set, and it will query me right to that data set and show me that file. What I can also do in this application, or in this tool, is I can load the selected scene into ENVI. I can either load the multispectral, the panchromatic, or pan-sharp, and these are all tools that are available within this extension tool. And when I hit load selected scene, it will actually load that data into ENVI without download. It's pulling directly from the cloud using ENVI's capability to consume remote web service data. So what I'm going to do is I'm going to show you, I'm not going to load that data, I'm going to show you data that I've loaded previously that I've loaded in and I've run an analytic on. Because once this data is loaded within ENVI, it is like any other ENVI data source. So this is that scene. It was a scene over Salt Lake City. And you can see this is a real Landsat data. I've applied a stretch to it within the ENVI display. And I've run a spectral index, the NDVI, on a subset. And I've actually gotten a result within ENVI. So the data, when brought into ENVI through this tool, is real ENVI data. All of the raw values are there, and it can be calibrated, atmospherically corrected, and analytics can be run on it, which I've done here, and this is an NDVI result. I did not have to download this data at all to get this result. The beauty of the cloud was when I ran the NDVI on this analytic, it actually went and ran the pulled only the pixels from the cloud that it needed to do the analytic, and it did it in a tile-based fashion. Okay. Okay, Jed. Did we lose Jed? We might have lost Jed, so we're going to go actually to the next polling question.
Okay, what other data sets would you use if they were available on Amazon S3? Here are the results. 38% commercial satellite imagery, 15% digital elevation model data,
Very interesting.
43% LiDAR data, and then 4% synthetic aperture radar data.
Okay, can people hear me?
Yep,
Yeah.
sounds good.
Okay, so I just switched to computer audio. Sorry about that. Okay, well, very interesting poll results. Do you want to go back to the last slide and I can explain a little bit about the tiled stuff? Do we have time for that? Okay.
Go.
So I want to expand a little bit on what Bo said about doing tile-based analysis. So this is, again, in line with our lab approach to making data available on S3 and in the cloud. We, based on some very good advice that we got from Peter Becker at Esri, I always want to give him credit for this, we use GDAL to add internal tiling on each TIFF that we make available via Landsat on AWS. And what this means is that we rearrange the binary data in the TIFF files so that you can query based on tile by doing what's called an HTTP range get. So typically with HTTP, when you get something, you're just getting an object and you get the entire file. But one thing that HTTP allows is for you to say, I don't want the entire file. I only want to get from this portion of the file to this other portion of the file, so that you can get just a chunk out of the middle of the file. This is really useful and very commonly used in making video available online. So if you've ever watched a video online and you've ever skipped ahead, what you're doing is you're doing HTTP range gets to skip ahead of the file. So what this allows you to do is basically skip ahead in a GeoTIFF or at our Landsat scene and say, I don't want to look at this whole scene. I only want to look at this one field or this one area of interest for me. And then you can do what are called range gets and get very, very precise bits of data for analysis, which can definitely add up. When you can retrieve only a few kilobytes rather than megabytes, you can really speed up and make your analysis more efficient. So next slides, or skip the poll again. So, and again, thank you for answering the questions of the poll. It's very interesting to see LiDAR up on there. We're definitely looking hard at LiDAR these days, and we're looking to for basically the next Landsat for us. Landsat was a huge success for us. We were very happy to see what the reaction was when we made it available. As of right now, there are over 400,000 scenes available, and within the first year, we recorded over 1 billion hits on the data, and that's 1 billion requests for data for those files. And so we know, there's no baseline for this. Like, we've never made similar data available at this scale, but we know that when you see that degree of activity, that it's not an accident. And what's more inspiring to us is what we've seen our customers do with it. So we're always really interested in serving our customers and enabling them to do things they couldn't do before. And so we've seen many customers, including Harris, obviously, produce new services and products and show off new capabilities because of the availability of the data. And that's exactly what we're trying to achieve. Next slide.
Okay, now I'm going to switch from the desktop to the cloud, but kind of just go over what we just did on the desktop. So how does ENVI consume AWS Open Data? I just showed you prior to the poll. I showed you a demo of ENVI directly opening up the Landsat AWS resources using what it was using was the image service support built into ENVI, and this came with that search and discover mechanism. Now where I'm going to move on to is the cloud, and there's several ways that we can access within the cloud. So what we can do is we can create Esri-powered apps using image services and ENVI analytics. Because of the nice wrapping of AWS with Esri image services, this makes creating these types of apps very straightforward, and I'm going to show you 2 of those in the next slide. But we can also have direct access of AWS S3 resources using ENVI tasks. And ENVI tasks are the core components that are used to publish analytics as web services through the ENVI services engine. And we have direct support of addressing S3 scenes within this task-based interface. And what I have on the screen here is an example web service call that could be used to apply a spectral index task or analytic to a Landsat scene directly accessing the S3 address. And this is possible now in the ENVI services engine and the ENVI task engine. And that is the technology that's going to be used in the next demo. So the first of 2 demos that I'm going to show you on the web is one that does change detection using Landsat data. So this is going to use the AWS Landsat service as its data source, and it's going to use tasks, ENVI analytic tasks, that are served up by the ENVI services engine. So this demo, I'm going to show this in a web client. So this is just a web app that's run off of this public address. This address is available to hit if you want to play with this after the webinar. And what it allows me to do is go to any area in the world, because Landsat data is everywhere. And what's happening is on this web map, I'm actually querying, every time I move the web map, I'm querying the AWS service or the AWS Landsat service for available data. And this is all of the data that's available within that service. So all I have to do is pick 2 dates. I'm going to pick, this is an agricultural area, and I'm going to pick a time in April of this year and also in the end of July. And I can actually see overviews of the 2 scenes. And what I'm going to do is I'm going to run a change detection on these 2 scenes. But this is going to be a change detection that is not just going to subtract the pixels. Before it subtracts the pixels, I'm going to run an NDVI on the input data set. So I'm going to actually do a change detection on the NDVI results. This is a workflow that would be very complicated to do on the desktop simply because of the amount of data that I have to pull down to my desktop. I would have to pull each one of these scenes down to my desktop, the full gigabyte worth of Landsat data. In this web context, using the Amazon Web Services, I'm only pulling the tiles that I need onto the cloud, and the analytics are happening on the cloud. No data needs to be downloaded to this desktop app that I'm running on right now. So what you're seeing on your screen is you're seeing a workflow of tasks, a change detection workflow going on. It's happening on an Amazon EC2 compute node, pulling the data from the Landsat scene, and within a couple seconds you should see change detection results show up on the screen for these 2 scenes. And they should come in about 2 seconds. And there we go. So what I'm going to do is I'm going to switch my base map and see lots of change. Blue is an increase in change, red is decrease. And you'll see that this lines up along the agricultural fields here. There's a lot of activity going on in this time period in this area. So again, this is the change done only on this area using NDVI as the baseline for both of these two images. So again, this is a demonstration using the Amazon Web Services as the data input and ENVI as the analytics engine. Not so easy to do on the desktop simply because of the data that has to be brought down. The next demonstration that I'm going to show, and the final demonstration we'll show here, is another view, another analytic demonstration that we can do. In this coverage, we're just going to show how to map snow coverage on an area with an app that is using, again, AWS with Landsat. So for this, what I have is I have an application that is meant to be very user-friendly, and it allows me to go to an area, to any area on the globe. In this case, I'm going to go to an area typically very snowy. This is Vail, Colorado. And what's happening is it's querying the Landsat archive, and it's bringing forth a scene of data. And what I want to do is I want to zoom into the ski resort here and map the snow coverage around the ski area. So what I can do is I can pick a date, and I'm going to pick a winter month here. A scene in the winter. Let's pick March of this year. And when I pick that data, I can get an overview of what the Landsat data looks like for that time period. The data should be coming to me soon. Let me try that again. No, let me try this. Select the date. I will pick, I'll pick another scene, January, and see if I get an overview this time. And there's my overview, and what this is showing me is that the scene that I picked is relatively cloud-free, and this is very good for analysis. So I'm going to then pick the snow icon here, which will run a normalized difference snow index. So this is going to go and grab the data from the Amazon server, and then it's going to run the index, and it should deliver me the results into this browser. Using the results will follow this legend that I'm showing here. And normally it doesn't take this long. I'm going to wait a couple more minutes. Oh, it's taking its time. So I'm going to let that go, and I will show that result when it comes up. And I'm just going to move on to our next slide. So, and this is our final slide, because what we can do now, now that we have data served on Amazon paired with cloud-based analytics, is we can now open up new platforms for doing analytics that we traditionally wouldn't think of as geospatial analytics platforms, such as a mobile device. So we have an app that was built by one of our partners called Optensity using a software called App Symphony. And what this app does is it runs through spectral indices purely on an iPhone platform. So it's called the Vegetation Health Monitor, and it is an iPhone app where you can select any area of interest, go in, run a selected set of spectral indices which are tuned towards vegetation health, and get results right on your iPhone. And you can imagine the possibilities of what you can do with a tablet or an iPhone here. You can go anywhere, get your location from the GPS on your phone, and get almost instant feedback on what the vegetation health is based on the last Landsat scene that was delivered. So this is just showing you what is possible, and almost anything else is possible with this type of access that we now have. So with that, we are done with our webinar. We'd like to thank you for attending, and I think I'll turn it back over to Jody for questions.
Yeah, great. Thank you, Bo and Jed, for the informative presentation. At this point, they'll address some questions that have come in. As a reminder, you can type in your question using the question area of your GoToWebinar dashboard. So the first question, I think this pertains to the demo you were trying to run. It says, so you actually went to Amazon Cloud to retrieve the data, and that would take some time, right?
It's not going to take that much time because of a couple of factors that are occurring. One is that the demo is run on an Amazon EC2 instances. Data access between the Amazon EC2 and the Amazon S3 are very, very fast. And also, I'm only pulling the data and the bands that I need for that analysis. So for the NDVI analysis that I did in the change detection analysis I did in the first demo, I only need one band, and I'm limiting the area. So I'm solving a couple problems. I'm only pulling a small area, and I'm only pulling the bands out of that area. So you do have to bring the data, but you don't have to bring that much data, and the platform is very performant.
Great. Are there geographical limitations to your data? Can Landsat images of West Africa be accessed as well?
So I can field this one. So right now, the Landsat 8 data that we make available is global. So we bring in absolutely everything and make everything available, including Africa, including Antarctica. We don't make any decisions on based on geography right now.
Great. Is there a charge to access Landsat data on AWS?
There is not. So data that's available via our public datasets program, for the most part, is available over plain HTTP. So people can download scenes if they want to. What's been interesting, though, is to see that the vast majority, and I mean over 99% of the data that's accessed from the Landsat bucket is accessed from EC2 servers. So most of the activity happens in the cloud, but if you do want to download stuff locally, you can if you want.
Great. I think this one's for you, Jed, as well. What percentage reliability does AWS guarantee?
So it depends on the service, but we do offer SLAs on almost all of our services. I wish I knew them off the top of my head, but I can look one up right now. So for instance, for Amazon S3, we offer a monthly uptime service, so ensuring that data that's available in S3 is over 99%. But anyway, we do have public SLAs that are available for most of our services, and you can look those up on the website.
Okay. Is the Landsat 8 query tool for ENVI freely available?
Yes, it is. We will put that up on the on our extensions website, which is available off of Harris Geospatial after this webinar, and it will be freely available. All it will require is an ENVI license.
Great. Jed, this is also for you. Is there a free trial of AWS?
There is. So we offer a free tier for, again, most of our services. And if you just go to aws.amazon.com/free, you can see what's available to you under that free tier. But it's a free 12-month tier of service for most of our services.
And this is also for you, Jed. What other data sets are available on AWS?
So our program makes all sorts of data available. Mostly it's actually genomic data, so it's not just Earth observation or raster data. We have a partnership with NOAA right now. We're working with NOAA to make some of their data available, and we make NexRad high-resolution Doppler radar data available on AWS, and so you can search that on the internet for NexRad AWS, and you'll find a landing page for that. Otherwise, if you just search for AWS public data sets, you can go to our public data sets landing page and see what we have there. And I want to thank everybody again for participating in the poll earlier, because we are interested in bringing on more geospatial data, and so it's good to hear what people are interested in. One thing that I can say, we haven't done it in the same manner that we've done with Landsat data, and that we haven't made an official announcement, but we have given a grant to a company called Synergize. It's a Slovenian company to explore ways to make Sentinel-2 data available on S3, and they've been doing, and so if you search for AWS Sentinel-2, you should find the landing page for that. If you don't find it, you can email me at jed@amazon.com, and I can point you to that. But all Sentinel-2 data that's been made that's been produced so far is available on S3.
Great. I'm not sure who can answer this one, but have you ever evaluated the change detection tools on pre- and post-fire wildfire locations for rehab and stabilization efforts?
I believe we've had customers that have done that. We have. I have not personally done that. The workflow could be applicable. I mean, there's various options to the workflow, such as running them against a burn index, and that could that's one of the built-in indices of ENVI. So that can be thrown at the problem, but I personally have not tried that.
Is there any cost for accessing the Landsat data in S3 where we can download the extension for ENVI? I guess those are two separate questions. So the first question is, what is the cost for accessing the Landsat data on S3?
So there's no cost to access the data.
Okay.
Yeah.
Yeah, and the extension will be made available through the extensions page, which you get to through harrisgeospatial.com. You go through your customer login, and you will see extensions, and we'll get that up there in the next couple of days.
Great. And then is the Landsat MSS Data, I guess 1972 or earlier, will it be archived in AWS?
We don't have any immediate plans to do that, but we are taking a look at other historical Landsat data and ways to bring that on. But I can't comment on the timeline or any concrete plans right now.
Right. And then what other very high resolution data from commercial satellites?
So I guess I would say one of the challenges or limitations of our public data sets program is that we only make available data that is freely available and not restricted by any sort of license requirements. So that typically means government data that is also usually moderate resolution. We work with a lot of commercial satellite companies. They're customers of ours, and they store their data on AWS, although they don't do it publicly. But they're increasingly storing their data in S3 and making it available in the cloud. Stay tuned, though. We do have a new public data set coming out, hopefully before too long, that will include some higher resolution data. And you can email me on that if you have questions.
And then this will be the last question. What is the main difference between online ENVI applications and Google Earth Engine? Are they comparable? Limitations?
So the ENVI's cloud offering, the ENVI Services Engine, is just it's a collection of over 200 analytical tasks, which are analogous to tools that we have in the desktop ENVI, and they're based on the desktop ENVI tools, and they're available as web services that can be called from clients. What you saw in the webinar are two example clients that use those tasks. So the main difference between Google Earth Engine would be, Google Earth Engine provides a platform to create your own, I believe, and they might have some out of the box, but ENVI has all of its tools that come out of the box, the tools that have been in ENVI for many years, and the tools that are evolving as we continue to develop ENVI. That's what comes with ENVI. But the ENVI Services Engine is not a platform as much as it is just a collection of components that could be seated on a platform like Google Earth Engine.
Great. With that, we're going to wrap things up. We appreciate everyone's attention on the line, and thank you again, Bo and Jed, for the great presentation. If we didn't get to your question, then either Bo or Jed will follow up with you later. And just a reminder that the recording of this webinar will be emailed to you in the next 24 hours. It will also be available online at www.harrisgeospatial.com, and we encourage you to share it with your colleagues. Thank you, everyone, and have a great rest of the day.